All right, so here's day 2 of solving our graphing with intercepts. So we're going to work on this one here. We did that one yesterday. How do I find the x-intercept? Zero in for y. Take my equation, multiply, 3 times 0 is 0. So my x-intercept is -9. -9 for x. I plugged in 0 for y, so that's how I know my 0. How do I find the y-intercept? Put 0 in for x. Go back to your equation. Solve for y, so in this case I'm dividing, and I get -3, so I have 0, -3. Why is the 0 second in this answer and first in this one? Now I need to be able to graph. X-intercept, -9, 0. So I go to -9, 0, and put a point. Y-intercept, 0, -3, 0, -3. From here, I graph my line. That's how you graph using X and Y intercepts. Plug 0 in for the other variable. So yesterday I told you we would talk more about today's answers. So you can use the graph you created to find solutions sometimes. So if we look here at this graph, any place where the graph goes through a solid line, a joint, a corner. So right here, that's a solution. So that's 8, 12. 8, if you remember, this was small tables and that was large tables. So we have 8 smalls, 10, read that wrong, 10, 12, 10 small tables and 12 large tables. Do we see any others? Yeah, right here, 20 small tables and 6 large tables. That right there where it goes through a corner. Now, if you're sketching this by hand, you won't be able to tell, but hopefully on the computer you'll be able to see some solutions. So the problem said, what were 4 other solutions? Let's see if we came up with them. 0 and 18, 10 and 12, 20 and 6, and 30, 0. So those are all points, and you can get those by looking at the graph and seeing exactly where it goes through on a corner point to get solutions. All right, so let's practice this again. So it says here you want to rent tables from a different company with this situation. 4, 6 equals 180. X is still small, Y is still large. So again, if I want the x-intercept, I put 0 in for y. I know 6 times 0 is going to be 0, so I just kind of skipped a step there. 4 goes into 180, 45 times. So this is 45, 0. If I want to find the y-intercept, put 0 in for x, that's 0. I get 6y is 180, divide y is 30, so that's 0, 30. Now, yeah, I'm going to go by 5s again. 5, 10, 15, 20, 25, 30, 35, 40, 45. 5, 10, 15, 20, 25, 30. There's the graph of my solutions. So if I had good graph paper up here, I would be able to look and see, I wonder Maybe that's a solution. Now it's not great graphing here, so I can't really tell. It might be off a little bit. I can check algebraically though, 5, 10, 15, 20, 5, 10, 15. And I can plug, so this is 20, 15, 20 small, 15 large. So algebraically, I can check and see if that's a solution by going back to my equation, plug 20 in for x, 15 in for y, and see if it works out. Well, 4 times 20 is 80. 6 times 15 is 90. Is that a solution? Nope. I'm going to be 10 people short. All right? So this is not a solution. It might look like it is because I have a very rough graph here, but it doesn't work when I double check the algebra. So any solution you might see on a graph, you can always double check that solution algebraically. All right? Of course, if you have good graph paper and you have a good line, it's a whole lot easier to see exactly where those points may be. All right, boys and girls. You know the deal. Get to work, ask questions.